Hello everyone, welcome back to my channel, The Physio Vlogger. It's been a long time, but we are back with a bang. We are going to start the series of learning biomechanics through easy tips and tricks. We will be starting with learning the biomechanics of vertebral column. So let's get started on this journey of learning biomechanics through easy tips and tricks. Vertebral column is a complex structure and students generally find it difficult to remember all the characteristics of the vertebral column region-wise. So the simple trick to remember vertebral column and the kinetics and kinematics of vertebral column is divide the vertebral column. Whenever we start writing an answer or start reading vertebral column, it should be divided in the portions such as, first you should always start with the introduction. The introduction includes all things about disc, lamellae, body, pedicles, everything. And then it has to be divided according to the region, which is cervical, thoracic, lumbar, sacral, pelvic floor and pelvis. So this is a simple trick to remember everything in detail about vertebral column. So now let's begin with vertebral column. We all know that vertebral column includes 33 vertebrae and 23 intervertebral discs. It is briefly classified into 5 regions, which include cervical, thoracic, lumbar, sacral and coccygeal. Cervical includes 7 cervical vertebra, thoracic is 12, lumbar is 5, sacral are 5 but they are fused to form 1 and coccyx they are also fused. Whenever a baby is born, in the womb, in the uterus, the vertebral column is of convex shape. To understand concave and convex, we need to draw a diagram. Suppose this is your vertebral column at the birth. This side is said to be concave and this side is said to be convex. When the baby is in the womb, according to its position, all the curves of the vertebral column, they are convex. So the vertebral column is convex posteriorly. As the baby starts to walk and hold the head upright, what happens? There are curves which get developed. This convexity posteriorly turns into something which is said to be like this. So the cervical becomes concave posteriorly and the lumbar region becomes concave posteriorly. So the curves which are present from the birth, they are said to be primary curves. And the curves which get developed later on, they are said to be secondary curves. So this is an important Viva question. The examiner can ask you to name the primary curves and the secondary curves. So the primary curves include the thoracic curve and the sacral curve. And the secondary curve includes the cervical and the lumbar. Primary curves, they are convex posteriorly and secondary curves, they are concave posteriorly. The vertebral column cannot be a straight structure like a bamboo because it will provide no flexibility if it is like this. The curve needs to be somewhat like this so that there is free movement which is possible in the vertebral column. The another important thing to remember in the introduction part of vertebral column is mobile segment. This can be asked as another Viva question plus a 5 marker. Now what do you mean by a mobile segment? The exact definition of mobile segment is when you have two adjacent vertebra plus an intervening disc and all the soft tissues that secure them together, that is said to be a mobile segment. So whenever a mobile segment is asked, it is preferred to draw a better diagram than this, of course, and mention about the intervertebral disc, the adjacent vertebra and all the soft tissues which secure them. Now, in general, in this whole chapter, whenever we talk about vertebral movements are named by the cranial vertebrae moving and not the caudal vertebrae. Now what do you mean by cranial vertebrae and caudal vertebrae? The vertebrae which is above towards the head, it is said to be cranial vertebrae, and the vertebrae which is below towards the legs, they are said to be caudal vertebrae. So movements, whenever we'll be talking in this chapter, the movements of vertebral column will be named by the cranial vertebrae and not the caudal vertebrae. Now next we'll be studying about a typical vertebra. The introduction part includes a typical vertebra. Always make a diagram so that it's easier and more presentable in your answers. A typical vertebrae is divided into the anterior portion and the posterior portion. Anterior portion includes the vertebral body and posterior portion includes everything which is pedicles, transverse processes, lamellae, spinous processes and superior and inferior articular processes. Now, vertebral body is not only made up of cortical bone, but it's also made up of cancellous bone. Now, what is the reason for this? First of all, you need to understand the properties of cortical bone and cancellous bone. Cortical bone gives strength to your structure, while cancellous bone has a property which absorbs the weight. So, as this is a vertebral column, there is going to be weight transferred from your skull to all the spinous processes and all the vertebral bodies. So the body is not only cortical bone, but the cortical bone is surrounded by cancellous bone. This gives the ability to resist the forces and absorb the forces. So your vertebral body does not fracture suddenly. The posterior portion includes the transverse process, the lamellae, the spinous process, the facets, and the pedicles. Pedicles, they transfer all the load from posterior side to anterior side and from anterior side to the posterior side. The lamellae, it protects the spinal cord. As the spinal cord passes in between these vertebral bodies, the lamellae protects the spinal cord by acting as a roof for neural arch. The pedicles, they transfer weight, and all these posterior elements are present. There is something which is known as pars interarticularis. It is a portion of lamellae where there are maximum chances of breaking and leads to stress fracture. So that is what is included in the lamellae. Whenever you are writing the introduction part, always mention anterior and posterior part and describe every structure in detail. That will help you to remember the sequence also, and you will not forget and miss any point. After writing about all this, write about articular processes. The articular processes, they form a supportive column. Important thing to remember when studying about the introduction part is intervertebral disc. The intervertebral disc has two principal functions, which is it separates the vertebral bodies and it transmits the load from one vertebral body to another. Why it is important to have an intervertebral disc? For example, if you don't have an intervertebral disc, these are the bodies. This is one vertebral body and this is another vertebral body. If there was no intervertebral disc present, there would be no absorption of the force which would occur from skull to the vertebral body. There is nothing in between, nothing is present like a cushion to absorb this. Plus, only the movements which would be possible would be this translation movements. No extra movement would be possible in absence of intervertebral disc. Thus, it is important to have intervertebral disc as it will increase the available motion at the spine and also transmit the load from one vertebral body to the next. The intervertebral body, it increases in size from approximately 3 mm to 9 mm as you move from cervical to lumbar region. Now, why does this happen? Because in cervical region, you have load coming from skull only. So 3 mm disc is enough to absorb that much of force. As you move down towards lumbar spine, the loads on the vertebral body and the lumbar spine increase. Thus, it is important to have disc of 9 mm so that it can absorb more forces. Okay, now the important part of intervertebral disc is the intervertebral disc is made up of 3 elements, which is nucleus pulposus, annulus fibrosus, and vertebral end plate. Whenever you are mentioning about intervertebral disc, never forget to mention about all these 3 parts. And it has important functions. Each one of them has got its role to play. This is a typical diagram. For example, this is your vertebral body and this is the disc. The center of your disc will contain nucleus pulposus. The sides of it will be having annulus fibrosus, and then you will be having vertebral end plates. As such, there is no demarcation line which separates. It is not like that only in the center, in this portion only you will have nucleus pulposus. Then after say 20% of nucleus pulposus, you have annulus fibrosus. It's not always like that. But it's considered that the center portion will be nucleus pulposus. It may be 20%, it may be 40%, it just depends. Then you will be having annulus fibrosus, and then you will be having vertebral end plates. Now, nucleus pulposus is just like a balloon, a water-filled balloon. For example, when you are playing Holi and the water balloons which does not have full water and somewhat space is present like a jelly, nucleus pulposus is exactly like that. It contains proteoglycans, and proteoglycans have the ability to attract more water. So proteoglycans will attract more water and it will give that jelly-like feel to your intervertebral disc. It also contains type 1 and type 2 collagen. However, type 2 collagen predominates. Why is this collagen important? First of all, whenever you are mentioning about your intervertebral disc, you have to mention about the 3 parts. And as soon as you start mentioning about the 3 parts, always remember the things which are present in intervertebral disc, which is proteoglycans, collagen. Collagen also 2 types, type 1 collagen and type 2 collagen. Then, as a difference of point, nucleus pulposus has type 2 collagen and annulus fibrosus has type 1 collagen. Type 2 collagen has its own property and type 1 collagen has its own property. So, a fun fact for you all to remember is, whenever we wake up in the morning, we are a little bit taller compared to when we slept at night because your nucleus pulposus attracts water at night and your intervertebral disc increases in size. That is why you are a bit taller in the morning compared to at night. So this will act as a water balloon, and when compressed, the nucleus deforms and increased pressure stretches the walls of nucleus pulposus. Then you move on to annulus fibrosus. So in annulus fibrosus, type 1 collagen is more. Why do we require type 1 collagen more? Because this resists greater portion of tensile forces. The nucleus pulposus was giving more a jelly-like feel. Now that jelly does not move out whenever it gets compressed, and it does not move out immediately. What is that resisted by? It is resisted by your annulus fibrosus, and annulus fibrosus has got type 1 collagen more. Okay, and these annulus fibrosis is attached to vertebral end plates by Sharpie's fibers. There are small connections which connect this annulus fibrosis and your vertebral end plates, and they are said to be Sharpie's. So the last portion to be included in the introduction part is the articulations. Articulations means the joints which are formed between the vertebral bodies. So first is the interbody joint, which is formed between the two vertebral bodies, which is somewhat located over here, and another one is zygophysial joint, which is between the facets. So interbody joint is the joints between the vertebral bodies, and the available movements are sliding, distraction, compression, and tilting. And another type of articulation is zygophysial joint, which influence the total available motion of the interbody joint, and it's a type of synovial joint. So this brings us to the end of the introduction part. In next session, we'll be starting with the ligaments of the vertebral column, and then we'll move to the region-wise biomechanics of the vertebral column. If you like this video and if you have learned something from this video, do like, share and subscribe to my YouTube channel. Thanks for watching.